Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to solve natural logarithmic equations. Now, let's consider the following example. We are to solve for the exact value of k, the exact value of k, and check the result. Okay, so in this example, we're going to be solving and checking the accuracy of our final result. So let's say we have the equation for number 1, 4 times the natural logarithm of k plus 9 plus 10 equals 6. So in this example, we have a logarithmic equation where we have an operation inside the logarithm and an operation on the outside. Okay? All right, let's go ahead and solve this. So to solve this equation for k, what we're going to do is we're going to start by getting rid of the 10, and then we'll get rid of the 4, and then we'll get rid of the natural logarithm, and finally we'll get rid of positive 9. Okay, so that those sequence of steps will result in the isolation of k, which will be the solved state of this natural logarithmic equation that we have. Okay, so let's go ahead and get started. The 10 on the left side needs to go, so what we'll do is we'll subtract 10 from both sides of our equation. So what we're doing is the inverse operation of addition is subtraction. So when you subtract 10 from both sides of the equation, you end up with 4 times the natural logarithm of k plus 9 equals 6 minus 10. Subtracting, signs are different. You just keep the sign of the bigger, which is negative, so we'll have negative 4 here. Next number we want to get rid of on the left side is positive 4. 4 is being multiplied by this logarithmic expression here. So to undo multiplication, we are going to divide both sides by that coefficient. Okay? If we divide both sides by 4, on the left side, these divide out, and you're left with the natural logarithm of k plus 9. And on the right side, negative 4 divided by 4 is negative 1. Okay, now we need to get rid of this logarithmic function, natural logarithmic function. To do that, we're going to use its inverse, which is the natural base. So what we'll do is we're going to put a big E on both sides. So what we're doing is exponentiating both sides of the equation using the base of this natural logarithm as our basis of exponentiation. Okay? So just remember that, just a side point. Natural logarithm is basically log base e. So if you want to cancel this out, you're going to use the base of the natural logarithm, which is a natural base, as your basis of exponentiation. Okay? Alright, so on the left side, we are going to have a little natural logarithm of k plus 9 equals, on the right side, a little negative 1. Okay? Now what happens on the left side? We have two inverse functions composed with one another, e and natural logarithm. So what happens is that they're going to cancel each other out, and you are left with k plus 9. On the right side, we have e to the negative 1. E is ill because it has a negative exponent. So how can we resolve the negativity of this exponent? If you have a negative exponent, that negative can be addressed by reciprocating the term with the negative exponent. So reciprocation involves flipping. If you're in the numerator, you go to the denominator. If you're in the denominator, you switch to the numerator. Okay? So here, e is in the numerator position with a negative exponent. So when we reciprocate, we're going to have 1 over e to the same power, but with the opposite sign, which is positive 1. Alright, to get k by itself, final step, we will subtract 9 from both sides of the equation. Now, if you subtract 9, on the left side, we have k isolated, which is the goal. And then we have 1 over e to the first power is just e minus 9. Now, we can write 9 as a fraction, 9 over 1, because we want to combine these two terms. Now, how do we subtract 9 over 1 from 1 over e? We find the LCD, okay? So the LCD of e and 1 is e. So you multiply the 9 over 1 by e, top and bottom. And that results in k equals 1 over e minus 9e over e. Now that we have the same denominator, we can subtract the numerator, 1 minus 9e, and keep and just combine the denominators. Okay? So this is the answer we got. Is it correct or not? Well, let's go ahead and do a check. Okay? So let's check our work. So what we're going to do is simply substitute the answer we got into the question and see if we end up with a true statement. Alright, let's do this. So what we have is the following. Check. The original problem is 4 times ln k plus 9 plus 10 equals 6. Okay, so we want to check this where k is 1 minus 9e over e. Okay, so what's that going to look like? So what we'll have is basically the original problem with the answer substituted in the place of the variable. Alright, so we have 4 times the natural logarithm of, now instead of k, we're going to insert the answer we got, 1 minus 9e over e, like that, plus 9. Plus 9 plus 10 on the outside. The question is this left part, after you substitute the answer into the problem, is it equal to 6? Alright, so we'll focus our attention on simplifying the left side and hope that it simplifies into 6, which will show that our answer is in fact correct. Okay, so we'll start off by dropping off this parenthesis. We do not have any number in front of it to multiply it by. So we're going to have 4 times the natural logarithm of 1 minus 9e over e. This should be combined with 9, okay? Plus 10. Is it equal to 6? Now to combine these two fractions, recall what we did over here when we had negative 9. What format did we express 9 in order to combine with 1 over e? We wrote it as a fraction first, and then we proceeded to find the LCD. Okay, the same principle applies here. We're going to express 9 as a fraction, 9 over 1. And find the LCD of the denominators, e and 1 again, which is just e. So we need to multiply 9 over 1 by e on the top and bottom. So we're now going to have 4 times the natural logarithm of 1 minus 9e over e plus 9e over e. Okay, plus 10, is this equal to 6? Now that we have identical denominators, we can add the numerator, 1 minus 9e plus 9e. This entire expression divided by, you combine the denominators into 1 since they're the same, plus 10. Is this equal to 6? That's the question. Now to simplify the left side of the equation, we're going to start working our way from the inside all the way out, okay? So examine this fraction in the denominator in the parentheses. What can be done to simplify it? If you notice, the 9e's are opposites of each other, so those two add up to 0. And we're left with 4 times the natural logarithm of 1 over e plus 10. Is this equal to 6? Now, I want to use the inverse property of logarithms to simplify this left side right here. But in order for that to work, I have to be able to express 1 over e as a power of e. So e to the what power is equal to 1 over e. Remember what we did over here? We had e to the negative 1. When we reciprocated, we have 1 over e to the first power. Well, we can apply the same principle here. We reciprocate and we have the desired form. 4 times the natural logarithm of e to the negative 1, which indicates a reciprocation of the original fraction, plus 10. Is this equal to 6? Now let's examine what we have here. We have a power, so we can use another property of logarithms. We can power down this exponent, negative 1, which will be multiplied by 4 to give us negative 4 times the natural logarithm of e plus 10. Is it equal to 6? Now, using the inverse property of logarithms, the natural logarithm of e is just the same as log base e of e. We have a composition of two inverse functions, so they basically take each other out. And you're left with negative 4 plus 10. Is that equal to 6? Negative 4 plus 10 is 6. Is 6 equal to 6? Certainly is. So this shows that our original answer, k equals 1 minus 9e over e, is in fact correct. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your study of logarithms, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions, comments, concerns, issues, or suggestions with what we covered in this presentation, just include it in the comments section below, and we'll be more than glad to respond. Don't forget to subscribe to our YouTube channel. We always update our page with math tutorials on a weekly basis. So if you like updates to our latest presentations, just subscribe to our channel so you can get notification concerning those updates. Don't forget to visit our website at mathgotserved.com, where you find a wide variety of tools to help you in your study of mathematics. Thanks again for watching, and have a wonderful day. Goodbye.